All right, in this video, we're going to talk about reducing algebraic fractions. Now, those are the same thing as rational expressions, but I want you to know that this is not a tutorial. It's not just a how-to. This is a lesson. So if you're just barely learning how to do this, this is the video for you because you're going to really understand, because we're going to introduce the concept and then we're going to do some conceptual practice problems. And then when we discuss your misconceptions, that's what we're going to use to develop some procedures. We're also going to do some other problems at the end that you can practice. And then, after that, you'll really understand. So let's get started with, talking about the procedure. Now, what I would try is I'd take just a moment to try these. Try all 6. Now, word of advice, if you don't try them and you're just trying to learn this, the mistakes you're going to make now, you're going to end up making later. And what that means is the things you should be learning now, you're not going to learn until later. So give them a shot. Pause the video, try all 6, just see how it goes. We'll revisit them here in just a minute at the end. Okay? So anyway, here we go. In a high school classroom, I have kids do this, and then I have them talk about it with each other. So what is reducing? Why does 5 over 10 equal 1/2? Well, the reason why is because fractions really ask a question. This is really saying 10 times what equals 5. And of course, it's 10 times 1/2 equals 5. And we got to keep that in mind because that's how we know if we're really right or not, okay? So what about 5 and 10? How do we end up reducing? Turns out that 5 and 10 have a greatest common factor of 5, right? 5 goes into both 5 and 10. And what we end up doing when we're reducing is we use division. We divide by the greatest common factor. So what we're going to do is we're going to divide both the numerator and the denominator by 5. And that's how you get 1/2, right? So reducing makes things smaller, and we use division. And if you're not sure, if it's not perfectly clear what it is you divide by, you divide by the greatest common factor of the numerator and of the denominator, okay? Now, you take a minute. What is it that you've got to know in order to reduce? You got to know the greatest common factor, right? You have to find the greatest common factor. That's a piece of background information that you absolutely must have. Greatest common factor. Now, I'll put a link in the video's description down below that you can, take a look at how to find the greatest common factor of algebraic expressions. And it'll help you out. So take a moment. What do you think it is? If I were to reduce 9ab squared divided by 3a squared b, which of these do you think it would be? Now, take a minute, write it out, try your best. Now I got to tell you, in high school, when students are just barely learning how to do this, it's a pretty even distribution between all of the possible answers. So the real question is, without going through a procedure, how can we know if we're right? Because just because you didn't make a mistake in your steps doesn't mean you're right. What if your steps are wrong themselves? What if the idea is wrong itself? So let's go ahead and take a look at this and see if we can figure out how we know we're right or not. So one thing we can do is we can actually take these answers and, change the denominator back to 3a squared b. And if the numerator goes back to 9ab squared, then you've reduced it correctly. So let's go ahead and take a look at the first one right here, 3ab. Now, in order to change 3ab back into 3a squared b squared, you'd have to put it underneath 1, and we have to multiply by something, right? We have to multiply 1 by something to get this. Now, of course, we're going to multiply by 3a squared b, like this, right? And what you do to the bottom, you have to do the top because this equals 1, right? This whole thing equals 1, and when you multiply by 1, the value doesn't change. This will look totally different, but that's kind of like the difference between a $5 bill and 5 $1 bills. Same amount, just looks different. So anyway, when I multiply these things together, I get 9a cubed b squared, which is not this. So this thing here and this thing here, they are not equivalent. So, not the right thing. Now, if you guessed A and you're wrong, that's okay, as long as you understand why it's wrong. And if you guessed the right answer, which I think it turns out to be D, but you don't know why, then that's no good either. So let's go ahead and take a look. See, that's wrong. And let's take a look at how we would do this. Now, when I see 9a squared b squared divided by, 9a b squared divided by 3a squared b, here's how I would do this to get my answer right here. What I actually see is I see the whole thing's separated. Like the numbers are separated like this, you see? The numbers are separated. They're being multiplied by the terms that have A, and those are being multiplied by the terms that have B. Let's go ahead and throw it over here on this side so we can do a little bit of work. Now, 9 and 3, their greatest common factor is 3. So I would end up dividing those by 3, and I get 3 over 1. Now, A and A squared, their greatest common factor is, of course, A. And in case you're not sure how that looks, see, this is A over A squared, and that's what I have right here, A over A squared. That's A times 1 divided by A times A. So when you reduce that, you're just left with 1 over A. Do you see? Now, B and B squared, their greatest common factor is B, and here's how this is working. B squared is B times B, and dividing by B, that's 1 times B. The B is reduced, and you're left with B over 1. Throwing that all back together, you get, 3B over A. All right, so let's talk about what we know. How do we know how to reduce? Do you know how to reduce? What is it you have to find out? Well, you have to find the greatest common factor, and you divide the greatest common factor out of all of the terms. That's how you know you're done. Now, how do you know when you're right? Well, you could convert it back. You could convert the denominators back, and if you got back the same numerator, you would know you're right. Now, one thing also, you have to reduce completely, which would mean in your final answer, the numerator and the denominator, they're called relatively prime or coprime. In other words, they don't have any common factors that they share other than 1. So here, you try this one. 24x squared y to the b divided by 30x y to the b. Right? Now, might get kind of confused right here because y to the b divided by y to the b, well, that looks ugly, but something divided by itself is just 1, right? So here we got Bobbert. Bobbert's this guy right here. Here's his answer. What do you think? It's actually wrong. Well, it's not really wrong. It's just not right either. You see, 12 and 15, they're not relatively prime. They're not coprime. They both share a factor of 3, so this could be reduced further. So it's not quite wrong, it's just not done. So Bobbert here, he's got another common answer, and, well, here's what he's got. How did he get that? See, y to the b divided by itself is, of course, 1. 6 goes into both of these, correct? 6 goes into 24 4 times, and it goes into 35 times. And here's what students do all the time. What they do is they just take their fancy pen, and they're like, oh, well, x goes into x, and x goes into x, and they're left with the 2 right here. And since that became 4, yeah, that happens all the time, and unfortunately, that's totally wrong. So that doesn't work. Well, let's go ahead and take a look at how this whole thing works, all right? Y to the b, like we said, divided by itself is gone. That's just 1, right? And look at the x squareds. X squared divided by x is, well, just x. So x to the 1, right? You don't scratch out the x. This one up here, x times x divided by x, and one of those x's reduces with the 1 on top. And of course, you divide 6 into 24 and into 30, and you're going to end up with 4/5. So when you put all that together, you get, well, you get 4x divided by 5. And that's all the way right. Now, how do you know if you're right? Well, a couple things. First of all, are the numerator and the denominator coprime? Do they have anything else in common that can be reduced? 4, 5, and x, they don't have anything in common. And the other way you could check is to multiply 5 times something to get it back into this right here. Well, yep. Now let's go ahead and take a look. Let's go ahead and try that, because this actually ties in with what's coming next. Not in this video, but the next topic you're going to learn is how to, well, add and subtract these algebraic fractions. So getting common denominators is going to be a big deal, you see. And so let's go ahead and take a look at this. In order to make 5 into 30x y to the b, well, 5 times 6 is 30, do you see? And we're missing an x, so we have to multiply by x, and we're missing a y to the b. But if you multiply that by the bottom, you got to do the same to the top. So this is going to be 24x squared y to the b, and yeah, that's right. That's what we want. That is exactly what we want. So reducing completely, again, that means that you go ahead and you take care of and you remove all of the common factors. So there are no factors left in common between the numerator and the denominator. That's how you are done. So in order to figure out how to do that, you always got to find the greatest common factor. So in the description below, I will leave some practice problems for you, a link, and you can try them and see how they go. Let's go ahead and take a look how you did on these right here though. Okay, 6 goes into 6 one time and it goes into 18 3 times. So if you got 1/3, I believe you got it. 2 goes into 6 and it goes into 20. So I think that would be right. And this one, do you see, it's the same thing. It's just, well, it's a reciprocal. It's flipped over. So we will reduce by 2 again, same thing. And I hope from the video you saw how these work. That's 1 over x, and this one's going to be, oh, wait a minute, x divided by x, isn't that just 1? So these two things right here would just become 1, and you're just left with an answer that's just 2. And this one, well, this is the one that I was hoping to talk about the most. X divided by x is 1, and so what you're left with is 1/2, and that's it. So why don't you try these two? And go ahead and try the problems that are in the link in the description and let me know how it goes. Anyway, if this was helpful to you, and I hope it was, you could just click like and maybe share it with people and leave me a comment. Let me know how it goes. And for lots and lots of help on these and all kinds of other topics, you can visit my website, thebeardedmathman.com. Again, this was not intended to be a tutorial, how do you do it? This was also supposed to, well, give you some background information so you could get a bigger idea of how to simplify these kinds of things. Now, if you're still confused, and you might be, after you try those homework problems, well, check out my website or the links, some of the links down below, and I will post in there a link on a little bit more straightforward. This is how you reduce, and we'll see how that goes. Anyway, thank you very much for your time, and thank you for watching, and I hope you have a great day.